Good day everyone, I am Princess Heidi Mancilia from 3SM BSed Mathematics, and today I will be presenting one of the fundamental topics in mathematics of investments. We have the ordinary simple annuity and the simple annuity due. This concept is widely used in managing savings, investments, and loans because it helps us to determine the value of a series of equal payments made over time. Throughout this presentation, we will learn what an ordinary simple annuity as well as simple annuity due is, how to identify it, and how to solve problems involving its future value and present value. So let's begin. Let us have first the ordinary simple annuity. Having our objectives, at the end of the lesson, the learners will be able to describe and distinguish ordinary simple annuity. Second, to compute either the future value, the present value, and also the term for an ordinary annuity. So to begin, when we say annuity, it is a series of equal payments at regular intervals. The length of time between successive payments in an annuity is what we call the payment interval. And the total time from the beginning of the first payments interval to the end of the last payment interval is what we call the term of the annuity. And the periodic annuity payment is sometimes referred to as the periodic rent. We can use annuities, for example, in payments of insurances, leases, loans, mortgages, pensions, salary, and a lot of more to mention. And these applications involves the present value and the future value of an annuity. And that depends to the problem or what is the problem asking us to find. Now, these are the following variables that we will use as mathematical treatment of ordinary simple annuity. We have N is equals to the number of payments in the annuity. R is equals to the size of each annuity payments, and I is equals to the interest rate per compounding period, which for simple annuities equals the interest rate per payment interval. And S sub n is our future value of an n payment ordinary simple annuity, and our A sub n is our present value of an n payment ordinary simple annuity. And this are the formulas we will use based on what the problem is asking us to find. You can take a picture or write it in your notebook before we proceed. Are you done? Okay, let's continue. We will first compute the future value of an ordinary simple annuity. So how do we identify if we should use the future value of an ordinary simple annuity? We have here, first is to check if there are equal irregular payments. Second, check if the payments are made at the end of each period. Third, check if the payment period and the interest conversion period are the same, if both are monthly, quarterly, or annually. Now we have here our first example. Xylee deposits 450 pesos at the end of every quarter into a savings plan that earns 7% compounded quarterly. Now if she makes 19 quarterly deposits, how much will she accumulate? Since we are asked how much will she accumulate, we will use this formula. We have the S sub n is equals to R multiplied to 1 plus I raised to n minus 1 over I. And this is the formula for, very good, the future value of an ordinary simple annuity. Now, we have here our solution. Our R, or the size of each annuity payments, is 450 pesos. Our M is 4 since the problem says it is quarterly. And our N, or the number of payments in the annuity, is 4.75 multiplied to 4 is 19. And our I is equals to 0.0175. So we will use the formula given for the future value of an ordinary simple annuity. So we have here S sub n is equals to 450 multiplied to 1 plus 0.0175 raised to n or 19 minus 1 over 0.0175. And the answer, if we add 1 plus 0.0175 raised to 19 minus 1 over 0.0175, we got approximately 22.31. And we multiply it to 450 pesos, we got 10,040 pesos. Therefore, Xylee will have accumulated 10,040 pesos. Now, what about computing the present value of an ordinary simple annuity? So we have here another example. Determine the present value on October 7 of 6,800 pesos paid at the end of each subsequent calendar quarter for 7 years if money is worth 6% compounded quarterly. Since we are asked to determine the present value, we will use this formula. A sub n is equals to R multiplied to 1 minus 1 plus I raised to negative n over I. And of course, we have here our given. We have our size of each annuity payments, which is 6,800 pesos. Our time is 7 years. J is 6%, and since it is quarterly or compounded quarterly, we have M is equals to 4, and our number of payments in the annuity, we have time multiplied to the conversion period, which is quarterly, so 7 times 4 is equals to 28, and our I is 0.015. So we will use our formula. We have A sub n is equals to 6,800 pesos multiplied to 1 minus 1 plus 0.015 raised to negative 28 over 0.15. And if we calculate inside the bracket, we got approximately 22.73, and we multiply it to 6,800, we got 154,541.67 pesos. Therefore, the present value of an annuity is 154,541 pesos 0.67. Now, what about computing the term of an ordinary simple annuity? So we have here our example. Kiana deposits 5,000 pesos at the end of every month into an account that earns 6% interest compounded monthly. How long will it take for her account to accumulate 70,000 pesos? Now, since we are asked how long will it take for her account to accumulate 70,000 pesos, we are asked to find the number of payments in the annuity. Therefore, we will use this formula. We have n is equals to log S sub n multiplied to R over the size of each annuity payments plus 1 over log 1 plus its interest rate. And we are given that our size of annuity payments is 5,000 and our future value is 70,000 pesos, and our interest rate, we have 0.005. Now, using our formula, we have n is equals to log 70,000 multiplied to our interest rate, which is 0.005 over 5,000 plus 1 over log 1 plus 0.005. Now, if we calculate that one, we got an answer 0.029383777769 over 0.0021660617757. Now, if we divide that one, we get n is equals to 13.56. Therefore, it will take Kiana approximately 14 months. Now that we understand what an ordinary simple annuity is, let us proceed to ordinary annuity due. Having our learning objectives, we have to define the key terms of an ordinary annuity due. Second is to compute either the future value, the present value, and also the term of the annuity due. So for our basic concepts, an annuity due is a type of annuity where the payments are made at the beginning of each payment interval. So if the ordinary simple annuity is always made at the end, the annuity due is always made at the beginning of each payment interval. And one of the examples are when equipment or property is leased, the regular lease payments are usually paid in advance. Now, these are the following variables that we will use as mathematical treatment in ordinary annuity due. So we have our N is the number of payments in the annuity, the R is equals to the size of each annuity payments, and I is our interest rate, and our S due is the future value of an N payment, and our A due is the present value of an N payment. And these are the formulas that we will use based on what the problem is asking us to find. Again, you can take a picture or write it on your notebook before we proceed. Are you done? Okay, let's continue. We will first compute the present value of an ordinary annuity due. We have here our first example. PXM Services acquired computers under a capital lease agreement. PXM Services pays the lessor of 300,000 pesos per year at the beginning of each year for 6 years. Now, if PXM can obtain 6 years financing at 10% compounded annually, what is the long-term lease liability will PXM report in its financial statement? Since we are looking for the value of today, we will use this formula. We have A due is equals to R multiplied to 1 minus 1 plus I raised to 1 minus N over I plus 1. So we have here our given. Our R, or our what we call the size of annuity payments, is 300,000. Our J is 10%. Therefore, our N is 6. Now, we substitute it to our formula. We got A due is equals to 300,000 pesos multiplied to 3.7907866769 plus 1. And if we add it by 1, we got 300,000 pesos multiplied to 4.7907866769. And if we multiply it, we got an A due is equals to 1,437,236 pesos and 3 centavo. Therefore, the initial lease liability is 1,437,236.3. And that is our present value of our ordinary annuity due. Now, what about computing the future value of an ordinary annuity due? Of course, we have our example here. So, we have here, how much will Emerson accumulate in his insurance policy by age of 60 if the first semi-annual contribution of 10,000 pesos is made on his 28th birthday and the last is made 6 months before his birthday? Assume that his insurance policy earns 11% compounded semi-annually. Since the problem asks for the accumulated amount in the future, we will use this formula. we will use the future value for an ordinary annuity due. So we have S due is equals to R multiplied to 1 plus I raised to n plus 1 minus 1 over I minus 1. And of course, we have here our given. R is equals to 10,000, I is equals to 0.11, M is equals to 2, our time is 32 years, N is equals to 64, and our I is 0.055. Now, if we substitute it to our formula, we got S due is equals to 10,000 multiplied to 572.0833916. If we multiply that, we got an answer 5,710,833 pesos 0.92. Therefore, Emerson will have 5,710,833 pesos 0.92 in his insurance policy at age 60. Now, what about computing the term of an ordinary annuity due? Of course, we still have our example here. Now, how long can an account sustain quarterly withdrawals of 3,000 pesos beginning today if the account contains 100,000 pesos and earn 8% compounded quarterly? Since the problem asks for the number of payments or periods or how long it will take to reach a certain amount, we will use this formula to find the N. So we have here N is equals to 1 minus log multiplied to 1 minus the A due minus R over R multiplied to I over log 1 plus I. And our given based on the problem, we have our A due is 600,000 pesos, or that is our present value which is given in the problem, and our J is 8%, and then since it is compounded quarterly, we have our M is equals to 4, and our size of annuity payment is 3,000, and our interest rate is 0.02. Now if we substitute it into our formula, we have 1 minus log multiplied to 1 minus 100,000 minus 3,000 multiplied to 0.02 over 3,000 over log 1 plus 0.02. And if we calculate it, we got 1 minus negative 0.45181538895 over 0.0086001717. And if we calculate that one, we got negative 52.53562394. So 1 minus negative 52.53562394, we get an N is equals to 53.54. So to answer the question, how long can an account sustain quarterly? If it contains 100,000 pesos and it earns 8% compounded quarterly, the answer is 53.54. To summarize our discussion, an ordinary simple annuity is used when equal payments are made at the end of each payment period, and the payment interval is the same as the interest conversion period. In an ordinary simple annuity, again, we discussed three important concepts. We have the future value, the present value, and also computing its term. We use the future value when the problem asks for the accumulated amount in the future, and we use the present value when the problem asks for the value of future payments today. And lastly, we use the term when the problem asks how long it will take or how many payment periods are needed. On the other hand, an annuity due is used when equal payments are made at the beginning of each payment period, while the payment interval is still the same as the interest conversion period. Similar to an ordinary simple annuity, it involves the future, the value, and also, the future value and the present value, and also its computing of the term. And the difference is that each payment is made one period earlier, allowing it to earn interest for one additional period. Therefore, before solving any annuity problem, because there's a lot of annuity, we have still general annuity, we have deferred annuity, always identify four things: the type of annuity, whether it is ordinary or due, whether it is simple, what information is given, and most importantly, what the problem is asking. Doing this will help you choose the correct formula and solve the problem accurately. And that concludes our discussion on ordinary simple annuity and simple annuity due. Thank you for listening, and I hope that you've gained a better understanding of these annuity concepts. Again, I am Princess Eileen Mancilia. Thank you for listening.